Okay, in this video I'm going to talk about the trend for electronegativity. Specifically, electronegativity is the measure of an atom's ability to attract the electrons that it's sharing with another atom in a bond. For most atoms, we can think of this as a measure of how attracted bonded electrons are to the nucleus of the atom, or how attractive the nucleus is. And so in a way, this follows the same trend as ionization energy, really with one exception, specifically the noble gases, as they aren't particularly attractive to other atoms' electrons. So this, in a sense, this video is basically a review of the video on ionization energy. So here's our periodic table. Something like that. And we're going to remember our trend for our effective nuclear charge, that this column's +1, this column's +2, this whole area is +2, +3, +4, +5, so on. And also our size, which is that every time we go down a row, we add a new shell. In terms of electronegativity, as we go from left to right, the effective nuclear charge increases. As it increases, that means that there's more attraction from the electrons to the nucleus. And so that means the electronegativity, or how much they pull on those electrons, increases. So somebody with his effective nuclear charge over here, like fluorine, has a high electronegativity, whereas someone like lithium over here with his only +1 has a low electronegativity. Now recall also that as we go down, so we're moving from top to bottom, we're adding more shells. This means the atoms are bigger. The electrons are farther from the nucleus. And so they experience less attraction. This means as we go from the top to the bottom and we get bigger, top to bottom, we get bigger, we have less attraction, which means the electronegativity, or how much they attract those electrons, gets lower. The notable exception here is the noble gases. They do not form bonds. So we generally don't even give them an electronegativity. So that's it. That's what electronegativity is. And that's how the changing effective nuclear charge going from left to right increasing makes electronegativity increase. And the adding of shells as we go from the top to the bottom makes the electrons in the atom farther apart, causing a decrease in electronegativity.